Hello everyone, I hope you are all doing good. In our fourth video, we discussed a domain agnostic design for question and answering, where a person asks any questions from different domain to chat GPT or perplexity kind of solution. So let's understand how the implementation will look like, how the agent will look like. Towards the end of this video, I have shared the agent and I have also shared the few inputs based on which you can try creating that agent using tools like N10 without coding and see if you give that kind of input how it generates the LangGraph object with all the nodes, edges and the flow of it. So let's understand the implementation part of it with some example. The two examples which I have considered at the end in the agent input is as a family of four going to a trip to Italy and in a budgeted cost of $4,000. The other input I took is creating a solution for a conferencing system where a person can ask questions about the conference agenda, conference venue, networking with the people, and also about the activities in the city, like where we can get the Italian food, where there is a concert in the evening, and so on. Okay, so for a blueprint for a scalable multiple agents solution, so the creating a orchestration and with the help of agent creating a LangGraph object. It will need an input for which we need to create a LangGraph object. It will pass through the Azure durable functions, or it could be AWS Lambda function, or other Azure app services, and it may use RAG, it may use web search and profile lookup. Okay, so to synthesize at the end, the output, it will need a use of a large language model or any language model cache which is used in the form of Redis, or for long-term history we can use Cosmos DB or DynamoDB on AWS. Cosmos is for Azure, right? The deployment part we will take in a separate session, where if we are deploying a solution for a small size of 1,000 users, or for 10,000 users, or for 1 million users, what is the configuration and the deployment changes we need to do, right? So just to give a hint, like in any electrical system there is a connected load and the actual load in use, which is very less. Similarly, hardly 3 to 5% people are actually connected, and with the inbuilt facilities given by Azure AI Foundry or AWS Bedrock, one can deploy for the large scalable number of users. So up to 1 million users, if you can deploy, it will easily be 20 times of that, means 2 billion number of users it will be able to handle. And the inbuilt facilities of configurations provided by Azure AI Foundry and Bedrock are good enough to handle such large number of users without any extra effort of doing the business logic change or using other services. If there are number of users are more than that, we can use step functions, we can use bus service, and each agent can be in a listening board on the bus, and whichever agents are needed more instance can be created of those particular agents. We'll go into details in a separate video. Let's continue our implementation part of domain agnostic agent creation. So one may ask a question related to airline industry or any other domain like sports and so on. So what is required is data ingestion, domain interface, memory state, and so on. So for different domain it can interface and get in knowledge, right? So the knowledge can be gained in the form of using SERP API or using RAG. So if you create a static chatbot, you create a LangGraph and object. We define all the nodes and edges, and whatever question we ask or for the domain, only that domain it can handle it. If we ask any question outside the domain, guardrail will reject it and the solution will not be able to answer it. So for creating a solution which can answer any question from any domain, we should be able to dynamically create the agents and the LangGraph object defining the flow of it. Okay, so how it can be done is user asks the question, the agent then creates a LangGraph object and spawns the new agents, right? And then it will use the memory available in the form of Cosmos DB, DynamoDB, or retrieval augmented generation using knowledge base in vector embeddings, or it can also use SERP APIs to make an external call and get the information, right? And finally pass on the response to the user. Some of the these components and agents like guardrails, cache, and those can be reused, and such configurations can be done where any dynamic node creation or LangGraph object creation can utilize the existing common objects or agents. Okay. So in a hub and spoke model, an orchestrator should be able to connect to vector store to retrieve information. It should be able to coordinate with executors. It should be able to gather information, the recent history of conversation with the user from Cosmos DB. Cosmos DB can be also used when the workflow is executing one agent to another. The agents can store the information on Cosmos DB, and the next agent can retrieve that information from the Cosmos DB. And the recent questions which may be asked by other users can be put into the cache, and if the same question is asked by another user, it can be retrieved from the cache, and the answer can be drafted again with the help of synthesizer and guardrail as per the recent history of the other user, chat history of the other user. So when we are designing such an agent which will dynamically create agents and LangGraph objects, you need to include different design patterns which are used in the creation of agents, like goal and planning, proactive goal creator, debate-based patterns, self-reflection, guardrails and governance, query and retrieval. So what will goal and planning do? It will do the logical sequencing of multiple steps. Proactive goal creator, it will it will anticipate user needs. Debate-based pattern, it will do the agents debating trade-offs. Query and retrieval, so it will do the RAG plus SERP API calls. Guardrail and governance will moderate and budget the validation. Self-reflection, it will evaluate errors, bias and tone. And if required, it will rerun the cycle with updated set of information, right? like goal line planning, the execution can be in a linear fashion or the parallel fashion. So whenever it's parallel fashion, the next level a synthesizer needs to score it, and then based on that create the response. Goal creator, based on the user need, whether user wants like kind of basic novice kind of information or advanced information, or for a travel it is a budgeted trip, or more like lavish trip. Like suppose you can there could be a there was one website like Heapmonk which would do the air bookings, and they had used a new attribute called as agony, which was a mix of different attributes like cost and the amount of wait time between two flights and so on. Query and retrieval, so it will gather the information from knowledge base or using search engines. Guardrails and governance will check the input whether it's a relevant question or not, should it be rejected, and governance will take care of ethical AI, bias, and so on. Self-reflection is reasoning and act, so it will check the output, and it will do the critics of that output, evaluate it, score it, and then if required it will rerun the cycle. So refining chaos into structure. So suppose user gives an input like I mentioned to an agent, family of 4 want to plan 1 week of Italy trip to cover main tourist places, low cost, 4,000 USD budget. So if such an input goes to an agent, it should create a dynamically object, a LangGraph object with agents which will execute, and finally it will give the output. And this input can be converted into a JSON object kind of thing, which makes it easier for the solution to understand the input. So kind of unstructured data converting into semi-structured or structured data. So the agent when executed, it will create multiple agents and a LangGraph object. So the different agents in this particular example, it will create is a trip planner, activity scheduler, budget optimizer, and booking assistant. A trip planner role would be of an orchestrator. It will take the input of the JSON object, and it will give the itinerary list based on the time given mentioned by the person asking the question. Then activity scheduler will schedule the activities, and it will find what the family can be do on this particular time and period, and it will rank it and the number of hours required to visit each of those places, right? Then it will pass on that output to the budget optimizer. Then based on the budget and the time required and the importance of the place to visit, it will optimize the places to visit. It will do the critics. It will be doing the persona of a critic, and accordingly discard some of the inputs given by the activity scheduler, and based on the budget, it will finally send the output to the booking assistant, and based on that booking will be done. In the booking assistant, another solution can be integrated where it does the booking of the flight, and after booking of the flight, it can also do the car rentals, hotel booking, and or Airbnb kind of budgeted stays or OYO. So multiple agentic solutions can be integrated. Okay, So how the orchestration flow in a linear fashion will look like. Okay, so input refining will be done. A JSON object is created. That input is given to a trip planner orchestrator. So that trip planner will plan the trip. It will list out all the places to visit. Then the budget optimizer, we are based on the budget, time, and it will discard some of the inputs given earlier, and it will create the final itinerary list. And then the activities scheduler will plan the activities. In this case, if required, even a human intervention can be given, so that once the human accepts it, the next steps booking can be done, or if it is rejected, then the next cycle can be done based on the user input. In such case, the chat history can be maintained, and conversation can be optimized, and the cycle of trip planning budget optimizer can be run again. So once if there is any error at scheduling the activity, it will raise the error, and otherwise it will go to the booking assistant, and booking assistant can book the flights, rental cars, and hotel. So let's see how each agent will behave. So suppose the input is given, and how the debate will happen based on the output of the trip scheduler, right? So the trip planner gives the itinerary, and then the budget optimizer says that to optimize the budget, instead of using a rented car or a taxi, use the train. So instead, in the case of train, then hotel or the Airbnb booking has to be near to the train station, so the family can avoid save money. So this is a kind of my real example. Like 10 years back when we went to Hong Kong, we planned our itinerary 6 months in advance. We did the flight booking to reduce the cost, and then we did Airbnb accommodation next to the metro station, and where the Indian food was available in the morning, which could be one person could go and pack and return, and then in the evening, after taking food, we could easily reach home by metro. And so how the workflow would happen in case of booking. So like the booking request based on the budget will process it, and then if it is success, it confirms the booking. If there is an error, it goes back to checking the budget and doing the bookings. So this cycle can be done until the booking is confirmed, and there can be a human intervention. Okay. So a fully itinerary with of a user's input in the form of JSON object would look like this, and this input will go to the agent to create a agentic solution. So same thing, if it has to be done in a parallel processing. Multiple agents can collect the information, one from knowledge base using RAG, another for using SERP API from internet, and third from do the location search, and fourth can do the profile search. So this is solution for the next question, which is the conference assistant. And this response synthesizer can combine all the four input output of all the four agents and synthesize the output for the user, right? So how the questions can be parallelly handled in the, so like a query enhancer can take the input from the vector database, search engine, Google Map, and the Cosmos DB, which will have the user profile, and it will it is the next it is the agent which will enhance the information before calling the other agents and providing that information. Suppose like user profile, from which location it is, what are his interests, what profile it has, professional and personal. So that information will help to enhance the question asked by the user. Google Map can check the location of the user, and based on the location it can optimize the output and give higher score to the locations, places near to where the user is currently present, right? So let me take another example which I just thought of. Suppose you want to go to a restaurant, and with certain food you want to what wine can be drink, and user is at certain place. So in this case all this information the agent will act and give the output, and after giving the output, then if user asks the next question that I have this much budget, please help me find a restaurant with this budget. So in that case vector database or the SERP API call can be used, and that information can be gathered, and based on the score top 3 to 5 such places can be shared with the user. So for efficiency and governance, as always, for incoming guardrails are used. Before that, a cache is checked whether the same question was asked earlier. If yes, that response is directly sent. If not, then the guardrail filters it and rejects the question by giving a response in a user-friendly tone. If it's a valid question, then it is processed. So let's understand the different questions asked in the quiz. You can pause it and try to answer it. So let's the first question in the propose Italy trip planning architecture, which agent is specifically responsible for adjusting itineraries to find cost saving alternatives like trains instead of flights, right? Here are the options, and here is the hint. Next question: which Azure component is utilized to coordinate the workflow of multiple agents in a stateful manner, such as sequencing the trip planner and activity scheduler? Here are the options, and here is the hint. Next question: which design pattern is applied when the error handler agent detects a booking failure and determines whether to retry or escalate to a human? Here are the options, and here is the hint. In the conference assistant workflow, which database component is used to cache frequent queries to reduce the load on the primary Cosmos DB? Here are the options, and here is the hint. What is the purpose of human reflection agent in the agentic workflow? Here are the options, and here is the hint to get the right answer. Which agent pattern is used to provide proactive suggestions like since you loved Rome, try Greece after a trip is completed? Here are the options, and here is the hint. So in the 5th video we did prompt engineering. This questions will also, and this video will also help you improve your skills on prompt engineering. So let's understand this agent which creates the agentic workflow solution of LangGraph objects having nodes, edges, and which can be dynamically executed. So you are a technical and solution architect with expertise in generative AI solutions to create dynamic agent prompts and the Azure logic apps and actions, Azure durable functions, Azure functions, and calling them for durable functions or logic apps deployment in Azure cloud environment. Based on user question for any domain, the agent should be designed. It should support solutions like Perplexity AI, to whom a user can ask any question and get the answers, and history is preserved. Suggest agents are simple scripts where required. Provide the output in CSV format to create the agent so it is easy to read it accordingly. Create those agents. Request you to provide system prompts wherever agent. So here I am giving the format of the output. So you can pause and continuously read this complete prompt. At the end I have given the example, and also I have given additional information in the prompt. Right, I have also provided list of all the design patterns which it needs to use while creating such a solution, and provide the output which could be dynamically executed. And vary this prompt. You can put in any no-code solution like NA10, and after that you can try giving the input like family of 4 want to plan over 1 week of Italy trip to cover main tourist places, low cost, 4,000 USD. The next input you can try is mentioned here. You can read it and try, and similarly you can try different domains like protesting a property tax, or a student wants to know how you can plan and study after to get the admission in particular college or a stream after 2 years. So that kind of two agentic conversation also can be built using can be done using such a solution. Thank you for your time. I look forward to you in the next video. Thank you.